On the morning of March 20th, 2025, a group of engineers inside NASA's Jet Propulsion Laboratory in California sat staring at their monitors, waiting. The day before, they had transmitted a carefully written sequence of commands to a spacecraft. Not something orbiting Earth, not a probe cruising past Mars or Jupiter. A machine flying through interstellar space, more than 15 billion miles from home, racing away from us at roughly 35,000 miles per hour. Those commands needed over 23 hours just to arrive. Now, as the return data trickled in, also taking 23 hours to cross that same unimaginable distance, the team saw something nobody had expected. A set of thrusters, written off as permanently dead back in 2004, was starting to warm up. Considered dead, and that conclusion had been completely reasonable given everything the evidence showed. Then he added that it was yet another miracle saved for Voyager. That single sentence is really the doorway into everything this video is about. Not just one repaired thruster on one lucky day, but the entire, almost unbelievable chain of events Voyager 1 has lived through over the past year and a half. Because what this spacecraft has actually been dealing with, and what NASA has quietly pulled off in response, goes far beyond anything most people November that no object built by human hands has ever reached before. Once you understand the full picture, all of it stitched together, you start to see why the people who work on this mission talk about Voyager 1, the way you might talk about something that simply refuses to quit. Something that keeps discovering a way forward when every reasonable expectation says it shouldn't still be out there at all. Voyager 1 left Earth on September 5th, 1977, built for a mission that was only ever supposed to last 5 years, a flyby tour past Jupiter and Saturn to snap photographs and gather data before quietly fading into obsolescence. That original mission succeeded beyond what anyone had hoped for. The pictures came home, the science got done, and then, almost as an afterthought, the spacecraft just kept flying. It kept going through another decade while scientists watched in something like disbelief, then another decade after that, then another. In 2012, it crossed the heliopause, the invisible boundary marking where the sun's influence finally gives way to true interstellar space, becoming the first human-made object in history to leave our solar neighborhood entirely and enter the space between the stars. And still, it kept going. Right now, at this very moment, Voyager 1 sits more than 15 billion miles from Earth, so far away that its radio signal, traveling at the literal speed of light, needs upwards of 23 hours just to reach us. Everything you are about to hear happened to a machine running on technology designed in the 1970s, operating alone in total darkness, billions of miles beyond any possibility of a repair crew, communicating with home across a delay so long that every single crisis becomes an agonizing race against time. Let's actually walk through what happened, because the timeline over the past year and a half is nothing short of extraordinary. Start with the thruster crisis, because it was the first emergency of 2025, and the fix required has genuinely been described by the man who led it as a miracle. Voyager 1 relies on a specific set of thrusters purely for roll control, the job of keeping the spacecraft rotating precisely enough that its main antenna stays pointed directly at Earth. Lose accurate roll control, and the antenna slowly drifts off target, the signal fades, and eventually, two-way communication becomes physically impossible. For decades, one primary set of thrusters handled this job, but back in 2004, 21 years before any of this, those primary roll thrusters simply stopped responding, apparently the victim of a power failure inside their internal heating elements. From that point forward, engineers leaned entirely on a backup set of thrusters to keep the spacecraft properly oriented. By early 2025, though, those backups had developed their own serious problem. Fuel residue was steadily building up inside their narrow internal tubing, the exact kind of buildup that eventually clogs a thruster completely and stops it from firing at all. Engineers calculated the backups could fail as soon as the fall of 2025, and if that happened while the primary thrusters remained dead, Voyager 1 would have absolutely no way left to control its orientation. The antenna would drift away from Earth, the signal would vanish, and for all practical purposes, the mission would be over. So the team at JPL went digging. They pulled up decades-old engineering documentation, original wiring schematics, telemetry records stretching back to the 1970s and 1980s, trying to understand exactly what had actually gone wrong with those primary thrusters back in 2004. One engineer landed on a theory. What if the heaters themselves had never actually been damaged at all? What if, instead, a glitch somewhere in the power distribution circuitry had simply flipped an internal switch into the wrong position, cutting off electricity to the heaters without physically harming them in any way? If that theory held up, then in principle, a precisely built command sequence might be able to flip that switch back, restore power, and bring those long dormant thrusters back to life. But this idea came bundled with a genuinely frightening risk. Those thrusters had sat completely cold for 21 straight years. If the spacecraft's star tracker happened to drift even slightly out of alignment while engineers were mid-repair, the onboard safety software was designed to automatically fire the roll thrusters to correct course. And if those specific thrusters fired before their fuel lines had warmed sufficiently, the result could be a small internal explosion. There was no way to override that automatic safety trigger if the timing went wrong. The entire fix had to be executed with such precision that the heaters would finish warming the fuel lines before any automatic firing could possibly be triggered. On top of that technical tightrope, there was also a brutal deadline. On May 4th, 2025, the Deep Space Station 43 antenna in Canberra, Australia, the only dish on the planet powerful enough to send commands to Voyager 1 at its current staggering distance, was scheduled to go completely offline for a major upgrade, lasting from May all the way through February of 2026, with only a couple of brief operational windows in August and December. Miss that deadline, and the team would have no way to even attempt the fix until sometime in 2026, by which point the backup thrusters might already have failed for good. The commands left Earth on March 19th. They raced across 15 billion miles of empty interstellar space at light speed and reached Voyager 1 more than 23 hours later. Then the team waited another 23 hours for a response, nearly 2 full days of silence. And then the data came back. The temperature readings on the primary roll thruster heaters were climbing steadily. Within 20 minutes of the commands executing on board, that temperature spike confirmed it had worked. The thrusters that had been completely dead since 2004 had just been resurrected from a command sent across 15 billion miles of empty space. 6 weeks later, right on schedule, the Canberra antenna went dark for its long upgrade, and Voyager 1 settled into its extended communications blackout with the backup thruster crisis solved and the revived primary thrusters standing by as a genuine safety net. That was the first thing NASA never saw coming, an engineering emergency solved against a hard deadline from interstellar space using a repair technique nobody had previously believed was even possible, and the story was nowhere close to finished. Fast forward to February 2026. The Canberra antenna had just come back online after its 9-month-long overhaul, and the team ran what should have been a completely routine maintenance maneuver, a periodic roll used to recalibrate the spacecraft's magnetometer, something performed countless times over the decades without incident. But on February 27th, 2026, during this exact roll, something unexpected happened. Voyager 1's power output dropped. Not catastrophically, not anywhere near zero, but enough to immediately worry the engineers watching the telemetry stream. Nobody had caused this drop deliberately, and nobody had predicted it. Engineers quickly realized that if the power kept declining, it could trigger the spacecraft's automatic undervoltage fault protection, a built-in safety system that would start shutting down non-essential systems on its own to protect the critical ones underneath. So the team acted fast. On April 17, 2026, NASA sent a command deactivating the low-energy charged particle experiment, an instrument responsible for measuring the structure and composition of particles drifting through interstellar space. Mission manager Kareem Badarudin was blunt about it publicly, saying that shutting down a working science instrument was absolutely nobody's preference, but it was simply the best option available given the circumstances. The power had to come from somewhere, and the LECP instrument was the sacrifice, made to keep the truly essential systems running. After that shutdown, Voyager 1 was left operating just 2 functioning science instruments, the magnetometer, which tracks magnetic fields, and the plasma wave subsystem, which listens to the faint vibrations of interstellar plasma. 2 working instruments on a spacecraft that originally launched carrying 10. Here's the part of this story that turns it from sad into genuinely extraordinary. Even with instruments being shut down one by one, the data still streaming back from those final 2 instruments remains scientifically priceless, still revealing details about interstellar space that absolutely no other measurement in human history has ever captured. The strange, persistent low-frequency hum of interstellar gas that Voyager 1 first detected back in 2021 is still being recorded today. The magnetic field readings are still quietly mapping the structure of an ancient interstellar environment that no spacecraft has ever physically passed through before. With every week that goes by, Voyager 1 pushes deeper into territory that has never once been directly sampled by any instrument ever built by anyone, anywhere. And it is still reporting home. Then, in August 2026, the engineers at JPL finally attempted something they had spent well over a year quietly preparing, a maneuver they nicknamed, only half-jokingly, the Big Bang. Nothing to do with the origin of the universe, just their own internal shorthand for an incredibly delicate power management procedure, one so precisely choreographed that it required shutting down multiple onboard systems and swapping in lower power replacements, all simultaneously, in a single synchronized operation with absolutely no room for a do-over. They tested it first on Voyager 2, Voyager 1's twin, currently traveling in a completely different direction through interstellar space, roughly 13 billion miles from Earth. On August 4th, 2026, the JPL team ran the procedure on Voyager 2, switching off a set of power-hungry devices and simultaneously substituting lower power alternatives designed to perform the exact same functions while drawing dramatically less electricity. The trickiest part of the entire operation was thermal management. Both Voyager spacecraft run on radioisotope thermoelectric generators, devices that convert heat from slowly decaying plutonium directly into electricity. Those generators are not just powering instruments, they are also the only thing keeping critical onboard components warm enough to keep functioning at all out in the deep cold of interstellar space. If any critical component drops below its minimum safe operating temperature, it fails permanently with no way to recover it. That is exactly why the Big Bang maneuver had to happen all at once rather than step by step, because switching systems sequentially would have created dangerous gaps where critical components could cool past the point of no return before their replacements had fully taken over. The announcement came on August 4th, and the Big Bang maneuver on Voyager 2 had worked. Without it, Voyager 2 would have been forced to shut down yet another science instrument before the end of 2026, leaving it with just two, mirroring its twin's situation. Instead, all three of its remaining instruments are now expected to keep operating for at least another full year. The mission team immediately confirmed the same procedure would be attempted on Voyager 1 within the coming months. And if it succeeds there too, there is a genuine chance the team could even restart the low-energy charged particle experiment that was shut down back in April, potentially bringing Voyager 1 back up to 3 working science instruments instead of 2. Sit with that for a second, because there is currently no replacement mission for what these 2 spacecraft are doing. Nothing funded, nothing launched, nothing even on a defined development timeline could replicate what Voyager 1 and Voyager 2 are accomplishing right now. They remain the only in situ sensor network humanity has ever physically placed inside interstellar space. Every single instrument lost on either spacecraft represents a category of measurement that stops forever, a direct window into the interstellar medium that closes permanently, the kind of data that simply will not exist again for decades, possibly far longer than that. The JPL team understands this completely, which is exactly why they are willing to attempt something as delicate and unforgiving as the Big Bang maneuver on a machine now roughly 49 years old, running on a power supply weaker than a dim household light bulb, because the alternative is standing by and watching genuinely irreplaceable science quietly disappear. And in the middle of all this ongoing drama, in November 2026, Voyager 1 is set to accomplish something no human-made object has ever managed before. On November 18th, 2026, at 2:16 in the morning Pacific time, Voyager 1 will officially sit exactly 1 light day away from Earth, the first human-made object in history to reach that distance. A light day is simply the distance light itself, the fastest thing that exists anywhere in the universe, travels across a full 24 hours, which works out to roughly 16 billion miles. At that moment, any signal leaving Voyager 1 will take a full 24 hours to reach us, and any response we send back will take another full day to reach it. Really sit with what that means in human terms. Ask Voyager 1 a question Monday morning, and the answer arrives Wednesday morning. If something goes wrong and the team needs to intervene, 2 entire days pass before the intervention even reaches the spacecraft. The engineers running this mission are essentially performing delicate surgery through a 2-day phone delay on a patient that is simultaneously flying away from them at 35,000 miles per hour, growing more distant and harder to reach with literally every passing hour. And somehow, they keep succeeding. They keep reviving thrusters everyone had written off as dead. They keep shutting down instruments strategically to buy precious time. They keep executing maneuvers with names like the Big Bang, and they keep coaxing genuine science out of a machine that was originally built when the very first Star Wars film was still playing in theaters. What has been happening to Voyager 1 across 2025 and 2026 is not a story about a spacecraft slowly winding down toward retirement. It is a story about a mission that flatly refuses to accept it is finished. Engineers who refuse to give up. Scientists determined to squeeze every last available watt into something scientifically useful. A machine that keeps defying whatever limits it was supposedly built to respect, pushing further than anyone in 1977 ever planned, still finding things in the darkness that nobody expected it to find. When that final signal eventually arrives, whenever that day finally comes, when the available power finally drops below whatever minimum threshold any instrument needs to keep functioning, Voyager 1 will not actually stop. It will simply keep drifting silently through the interstellar medium and through whatever lies beyond it, carrying its golden record onward, along with the memory of every single person who ever worked to keep it alive this long. Roughly 40,000 years from now, it will pass reasonably close to a star called Gliese 445. By then, the civilization that originally built it will be completely unrecognizable, Our languages will have drifted beyond any hope of translation, and virtually everything humanity has ever constructed will have turned to dust. But Voyager 1 will still be out there, still moving. The single farthest thing humanity has ever built, carrying a message in a bottle thrown into the widest, darkest ocean that exists. And right now, today, at this very moment, it is still talking back to us, still measuring, still surprising the very people who built it, still finding ways to survive, when every reasonable expectation says it should have gone silent years ago. NASA genuinely did not expect those thrusters to come back to life. They did not expect the power drop in February. They certainly did not expect to still be pulling meaningful science out of this machine in 2026, nearly half a century after it first left the ground. Let's go a little deeper into what this whole survival story actually means. Because most people, when they hear about Voyager 1, tend to focus purely on the romance of it, the poetic image of humanity's farthest messenger drifting alone through the dark. And that part is completely real. But there is another dimension to this that rarely gets the attention it deserves, the sheer scientific weight of what Voyager 1 is still managing to collect. The interstellar medium, the vast space that exists between star systems, remains one of the least understood environments in all of astrophysics. We can observe it from a distance using telescopes, watching how light from faraway stars gets absorbed and scattered as it passes through that medium, and from that we can infer things about its density, its temperature, and its magnetic structure. But there is a massive gap between remote observation and direct physical measurement, between seeing something from a distance and actually being inside it, feeling its plasma waves and magnetic fields firsthand with instruments physically placed right in the middle of it. Voyager 1 remains the only object humanity has ever placed directly inside the interstellar medium, and the data it continues sending back is not simply confirming what scientists already assumed. In several cases, it is actively contradicting it. When Voyager 1 crossed the heliopause back in 2012, scientists were caught off guard to discover that the direction of the magnetic field out there did not line up with what existing models, built entirely on remote observation, had predicted. The plasma density was different than expected too. The transition from our solar system's protective bubble into true interstellar space turned out to be far messier and more complicated than the clean, tidy boundary earlier models had suggested. And then there is the strange magnetic anomaly that began back in 2020, an unexplained elevation in magnetic field readings that persisted for years, which some scientists now believe might indicate Voyager 1 has drifted into a pocket of unusually ancient interstellar plasma, something no existing model predicted, and that remains genuinely unexplained even today. Every scrap of data still coming back from Voyager 1's 2 remaining instruments functions as ground truth for theories about interstellar space that have been built almost entirely on indirect observation for decades. The magnetometer keeps tracking how the surrounding magnetic field shifts as the spacecraft pushes deeper into interstellar territory, building a running local scale map that remote telescopic observation simply cannot replicate. The plasma wave subsystem keeps listening to that steady hum of interstellar plasma, the continuous low-frequency signal produced by ionized gas vibrating out in the vacuum, giving scientists their only real-time reading of plasma density in the exact region Voyager is currently crossing. None of this is routine data collection. These are, quite literally, the only measurements of their kind anywhere in the known universe. Every individual data point is genuinely irreplaceable, and everyone at JPL understands that losing even one more instrument means a permanent gap that no future mission will be able to fill for decades to come. That is part of why the success of the Big Bang maneuver matters so enormously, well beyond just keeping the spacecraft technically alive. Its success on Voyager 2 means the same technique will now be attempted on Voyager 1 as well, and if it works there too, the mission team believes they may not only prevent the loss of another instrument, but potentially even restart the low-energy charged particle experiment shut down back in April, turning a dead instrument back on and pushing the spacecraft from 2 working instruments back up to 3. Buying more time, more data, and more genuine science from a spacecraft that has already outlived its original mission timeline by more than 4 decades. There is also the communication situation itself, which quietly shapes literally everything about how this entire mission gets managed day to day. As of August 2026, Voyager 1 sits roughly 15.8 billion miles from Earth, with a one-way communication delay stretching past 23 hours, but that distance is not fixed. It keeps growing. Every year that passes, Voyager 1 gets a little farther away. Every year, the signal it beams back arrives just a bit weaker than the year before. Every year, the massive dish antennas making up NASA's deep space network have to work just a little harder to pull that faint signal out of the background noise filling the universe. The 230-foot antenna in Canberra, which only recently came back online after its long upgrade, is part of an ongoing, deliberate effort to keep Earth's ground infrastructure capable of maintaining contact. As the spacecraft pushes into distances nobody has ever attempted to communicate across before. By November 2026, when Voyager 1 finally reaches that historic 1 light day distance, its signal will be so unbelievably faint that the camera antenna will essentially be operating right at the absolute edge of what current technology can physically achieve. There is no bigger antenna sitting in reserve somewhere ready to take over. The Deep Space Network genuinely represents the best humanity currently has, and Voyager 1 is steadily approaching the outer limit of what that network can handle. Future advances in signal processing and antenna design might stretch that communication window a little further still, but eventually there will come a point where the signal drops permanently below the noise floor and simply cannot be recovered. Nobody knows the exact date that will happen, but by any reasonable estimate, it is not especially far off. Voyager 1 just handed NASA something it was not expecting. Once again, it sent back the simple message that it is still alive, still functioning, still pushing forward into territory that no other object built by human hands has ever explored before it. Nobody planned for any of this back in 1977. This is not what the original mission was ever designed to deliver. It is simply what happened when a spacecraft engineered to last 5 years turned out to have been built far tougher than anyone realized, and was then kept alive across the decades by people who flatly refused to accept that it was finished. On November 18th, 2026, a signal will leave a lonely spacecraft drifting through the vast darkness between the stars, and it will spend exactly 24 hours crossing that unimaginable void before it finally reaches Earth. Voyager 1 will officially sit 1 light day away, the single farthest human-made object in all of history, still transmitting, still surprising us, still, after 49 years, finding things that nobody at NASA ever expected it to find. That is simply what Voyager 1 does. That is what it has always done. And for as long as a signal keeps making that impossible journey home, that is exactly what it is going to keep doing.